A warm welcome to Nandal after a long time. So, in today's topic, we are going to see about hydraulics and pneumatics. So, regarding hydraulics and pneumatics, in our previous classes, we have discussed many topics. So, in that, now we are going to discuss about the main topic about the hydraulic circuits. So, depending upon the hydraulic circuits, so there are many circuits. So, in order to make the fluid flow in a proper manner, that is from reservoir, lower reservoir to the upper cylinder, we need several components and accessories. So these accessories and components are arranged in several positions and several balls are being involved in it. So regarding the components, when you are seeing components, there are many components. So likewise, there are pump, motor, actuator or cylinder, and then we are having valves like direction control valve, flow control valve, check valve, pressure relief valve. So likewise, we are having many valves. So these valves perform several functions. So depending upon this function, the system works. So how the system actually looks, how the components are placed in order, and how each component is performing its own work. So likewise, we are going to see what are the components arrangements. That is a graphical representation we are going to see. So graphical representation in the sense it's a schematic representation. So how a hydraulic system looks. So you'll be having some block diagrams. In that block diagrams, we will be seeing how the flow continues. So due to the flow, how the system works. So we are going to relate this kind of things in this topic. Okay. So regarding valves, that is regarding the hydraulic circuits, there are many types of hydraulic circuits. So in this session, we are going to see only the two major important valves, that is the hydraulic circuits, which is being involved in our topic. So remaining things you can see in our next class. So now we can focus on the main the main valve, that is the main hydraulic circuit. Okay, so the topic which we're going to see now is counterbalance valve. Okay, the name itself implies that this topic is all about the counterbalance. Counterbalance in the sense, uh, for example, if you're taking a cylinder, okay, there are two ways of fluid flow in a cylinder. So when the fluid flows in the cylinder, assume that in a cylinder above the top we are having a weight. So we are having a dead weight. So due to that weight, what happens? Actually, the piston gets down of the cylinder. So due to gravity, what happens? The weight actually pulls down, is pulled down, the piston goes down. So when it goes down, it pressurizes the oil over there. Due to that pressurization, what happens? The oil splits. The fluid inside the cylinder gets splits. If it gets splits, what happens? The edges in the cylinder gets damaged and automatically leaks tends to come. So in order to avoid this kind of problems in an hydraulic circuit, we are going for a counterbalance pressure. So pressure in the sense we are opposing an opposite pressure to withstand that weight. So actually what happens in an hydraulic circuit, its main application is all about hydraulic press or hydraulic lift or hydraulic some examples. Okay. So what happens actually, there will be a weight in there. So our ultimate aim is to lift that weight. Okay. To lift that weight, we are using going for this kind of system. Okay. After lifting up of the weight, there will be no force will be supported to balance that weight. So to support that balance of weight, we are going for a counter pressure. So that pressure is what involving everywhere. So in this concept, okay, how it works you can see, right? So see, this is the sump which we are having at the bottom surface. So see the sump, so in which the oil is being filled over here. We already talked about this. So it's a sump, a reservoir where the oil is being, the fluid is being kept. Okay, so we're having, and now we can see the general components for the components involved in this. Okay, so we're having a pump. So this is a typical pump. Okay, so this pump is being actuated by a motor, electrical motor. Okay, so various energy conversion takes place, and then we're having a valve over here. This is nothing but a direction control valve. This is a direction control valve. This direction control valve is balanced by a pedal system. So this is a pedal. Okay. So when you press this by your arm or by using your leg, we're having a dead weight here, weight over here, right? And then we're having a pressure ratio. So after the fluid enters the cylinder and after the output of the cylinder, the fluid enters the pressure. So now to control the pressure, we're going for this pressure relief valve. Okay, so these are the components involved in there. And then regarding this direction control valve, so this valve is 4 by 2 valve. So it involves four sorry, involves four parameters A, B, P, T. So here A involves so this is a 4 by 2 valve. So which involves four. I'm clear about it. Can you hear me? Yes, fine. Yeah. So we are having a 4 by 2 valve. 4 by 2 valve in the sense four involves. We're having two inlets A and B, and we're having a pressurized port B, and are having a transfer port. So it transfers oil from one medium to another. So and then we're having this two implies that we're having only two positions. So this is position one, and then this is position two. So we're having two sets of positions here. So actually, what happens in this direction control valve? It controls the direction of the flow in two ways. The first position, the flow goes normally, and then in second position, the flow changes its path, and then it goes in another track. So that's why this position valve is designed in this way, right? So it is controlled by a spring extracted thing, right? So then we are having over here the check valve. So it checks how much of the liquid is being sent into the system. So this is a check valve. So now we can see the working of it. So as soon as when the motor is being actuated, the pump rotates in a very high RPM. So what happens? The oil in the sump it gets sucked and then it travels over here. It travels over this valve. So in this valve, the fluid flows from pressure port and enters the A chamber. So A position. and then it goes here, and then it settles over this cylinder. When it gets on the cylinder, it pushes the piston downward. So now what happens? Along with the weight, the piston goes down, and then the remaining oil is being sent over here, and then it gets down over here in this way. Okay, so inlet is from P to A, and then the outlet is from B to T. Okay, so this is a thing we are to see in the first position. Okay, the inlet is from P to A, and the outlet is from B to T. So it goes through the oil sump as it is. Okay, so this is one position, so first position. Then we are having second position. What happens in the second position? The flow is being transferred. The flow is being converted into some other type. So what happens now? This symbol indicates that this is A. Okay, so this is B. Now this is P and T. So what happens is that actually the flow is from now P to B, and then it goes from P to B, and then it comes from A to T. So what happens from the pump? What happens? The flow goes from P to B. Is being transferred B to B, and then it goes this way, and then it pushes the piston in this manner. So what happens? The weight goes up. The weight goes up. The weight goes up. It's being lifted, and operation is being done. So the output comes over here, and then it goes to the this way, and then it goes to the sump. So this is why the valves are being in this position, right? So this is a general working of this circuit diagram. But what happens here in the second position, when the flow goes like this way and then enters the actuator, what happens? It pushes the piston down. So what happens? According to the gravitational force, what happens? The weight also acts downward. When it acts downward, there is a chance of damaging the parts over here. So in order to stabilize this weight by not uh, damaging the cylinder, we are actually creating a pressure over here. So this pressure is supplied from this counterbalance valve. For example, if the weight is coming down, normally initially before this weight comes down, the pressure is around 8 kilopascal. Okay, so we have to supply a pressure above that 8 kilopascal. Okay, for example, I am supplying pressure of 13 megapascal. What happens? This pressure and this pressure acts over here and tends to move this weight in a slow manner. So without damaging the cylinder. Okay, so this is what we are actually doing. Simply saying we are applying a pressure above the pressure inside the cylinder. So what happens? It balances the weight over there, and it does not cause any damage in the cylinder, and there will be no leakage. Okay, this is the working of this counterbalance valve. I hope you understood what I told. So this is what happens here, right? So the pressure is being supplied in this direction to take to this places, right? So the pressure is being supplied from this counterbalance valve. So this is a counterbalance valve. Okay. This arrow box indicates the flow of action, right? And this is the check valve, which checks the amount of fluid entering and leaving the system. This is controlled by a spring retarded system. Okay, so then when the fluid comes down, we are having two sets of share. We are having a pressure relief valve. So where the pressure relief valve opens and accommodates the high pressure liquid inside. When this high pressure liquid is being accommodated, what happens? The pressure is being relieved over there. So this is how the pressure relief valve works. On the whole, we are seeing how the counterbalance valve works and what is the work is being done to avoid the damages to the cylinder. And then we have seen the circuit diagram, circuit flow. Okay, I hope you understood this topic. Thanks. So next topic we're going to see is mechanical hydraulic servo system. Mechanical hydraulic servo system. So the name implies that as well as a conversion of mechanical energy into hydraulic energy mechanism. So it's topic. Best example for this mechanical hydro that post. So the best example for this mechanical hydraulic servo system is a power steering, a typical power steering. Okay, as I told you before, our power steering works. Okay, so in the power steering, what happens actually? Uh, we are actually driving that steering. So what happens? Okay, so the rotation of the steering involves actually the mechanical work. So that mechanical work is being converted into easier work by applying hydraulic energy. So that hydraulic energy is nothing but the oil. So the oil is being supplied into the cylinder where the rotation for a complete rotation. Okay, so imagine that we are if we're not having a cylinder over here, assume that there is no steering. So imagine how we can drive a vehicle. So it reduces the driver's effort. So for a 45-degree angle of rotation, the wheel actually turns. Okay, imagine if we're not using a power steering, what happens? For that 45 degree of rotation, the wheel will turn only little bit. So what happens? It effortlessly reduces the driver's effort. So that implies that it's nothing but the mechanical hydro system. Okay, so mechanical energy is the rotational energy of the steering, and hydraulic energy is involved where the fluid flow is taking place. The fluid acts as the pressurized fluid acts as the steering control device. So it actually turns the wheel in a faster rate manner for a slight 45-degree rotation of the steering. Okay, so this is the mechanical servo system. So what happens actually here? So we are involving the parts steering wheel, pivot point, and servo system. So this is the main thing, servo system. Servo system in the sense, so this part is servo system. Okay, where the pressurized fluid from the pump enters into the system, and then according to the movement of the spool. So we are having three types of spools. So this spool, the So what is the lower portion in this same means? So this is the sump in which oil is being filled, and then we're having a filter over here which filters the stained parts from the oil, and then now we're going for a pump. We're using a pump over here, and then it is followed by a pressure relief valve, okay, which releases the pressure of the fluid, and then we're having a servo valve in which you're having three different spools. So in the spools, in this meaning will be the fluid is being passed over this spool, and then it enters this way, and in this way the fluid flows. Okay, and then we're having a cylinder over here, a master cylinder. The function of the cylinder is to actuate the fluid flow. From this actuation, what happens? The piston rod moves to and fro. It moves in right side, left side, and then it moves in left side and right side. What happens in this linkage? This linkage is connected to the wheel axle. Okay, so this linkage moves in a faster way, in a quick manner. So this quick manner is achieved from this cylinder only. So due to the movement, see the movement. Due to the movement of the fluid inside this cylinder, the piston rod moves. Due to the movement of the piston rod, the linkage moves. Due to the movement of the linkage, the axle turns. So axle turns means what happens? The vehicle turns left as well as right. Okay, this is what happening in a power steering application. Okay, so now what happens? The oil from the sump gets from the motion of the pump, enters the spool here, and then it comes over here, and then it enters the cylinder at this place. When it enters the cylinder at this place, it pushes the piston rod in this side. So when the piston rod is moved this side, means the linkage moves this side. The linkage moves this side. What happens? The tire turns towards your left. So depending upon the movement of the oil in the cylinder only, the rotation of the wheel is being involved. This is one case. In another case, what happens? The oil flows in this spool in this way, and then it directs to the cylinder in this direction. Now what happens? It pushes the cylinder in right side. When the piston rod moves in the right side, what happens? The linkage also moves in the right side. What happens? The wheel turns to the right. Okay, wheel turns to the right. Depending upon this only, the movement of the wheel is being actuated. So what happens? The steering wheel is being tilted to some smaller angles. After this tiltation, what happens? The pump actuates, and then oil flows through this region, enters the spool, and then it enters the pipeline and then goes to the cylinder. So this is what happening here. Okay, so this is a typical explanation about this mechanical hydraulic servo systems. I hope you understood the topic which I taught you now. Okay. So now we're having a pressure relief. So now we're having a pressure relief valve over here. What happens after the fluid is being entered, and then the fluid passes in the outlet. So after the outlet region, the fluid flows directly to this sump. When it flows, the pressure relief valve will release the pressure of the fluid. This the high pressure fluid is being converted into a low pressure fluid. So and then here it's being settled over here. Okay, this is the working of a hydro. This is working of a mechanical hydro servo system. Okay, I hope you understood the topic what I taught you now. Okay. So in another session, you can see a new topic. Take care. Bye.